Yeah, brother, go ahead.
Hi all, this is Amarendra Kumar. I am Principal Software Engineer at ViewClip, Pune. I mostly manage, maintain, and have written personalization engine for ViewClip. Um, so basically, because you watched titles of your when you watch something, you get a slide called as because you watched or top picks for you. All these in ViewClip is managed by me. So today here I am with you guys to deliver a talk on GraphQL. So we'll be looking at how REST has changed the world in the current world, obviously, and then how GraphQL on REST is making it better. Okay, so I have some slides, and then we'll be moving to implement one of the GraphQL servers as well. Okay, so hopefully you guys can see the screen on the right hand side. So what is REST? So when we talk about REST, you generally have a API, a link, where you have the resource which you have to interact with, and the endpoint and the verb that has to be acted on. So verb signifies the part of the API which the method that you will interact with, and the API is the resource which it will return. So let's say you want to hit this API, you get a list of data. Now, when I say a list of data, it comprises of the elements that actually returns the resources. Like, let's say you want to see what a user ID of 72 is returning. That gives me ID of 72, name, date of birth, place of birth. And it gives a list of external references as well, which is associated to this data. So when I talk about our model has, so since it's an OTT platform, a user is associated to a subscription, what all are his recently watches, and his address. Address can be a little more complicated based on email address, then your location, and it can be a little more complicated than simple address. So what I'm trying to say is, you for a RESTful endpoint, you get something in response back which is relevant to this particular user. Now, having said this, what it generally signifies is, let's say I have a RESTful endpoint like this. Whenever we want to have, I'll just make it bigger. So whenever we want to have a detail of what user subscriptions are, so we have to click on subscription. You get the subscriptions back. Similarly, you have to have, let's say, address. You click on address, and then you get the address of the user for the user ID 72. What it tells you that for a page to get built on the client side, you will have n number of calls made from the server to the client just to build one page. Let's say I want to build a user details page, and I need subscription, what all his top recently watches are, and his address, let's say email ID. To build this, I have to get the user details, one hit, second for subscription, third for recently watched, fourth for address. So I nearly hit 4 HTTP interactions. Okay, now, okay, now let's say when the client is your web server, or let's say a web browser, you will you will have you will have uh, 3 interactions, 4 interactions. It's fine. But if your client is a mobile phone, or let's say is on a low bandwidth, then it's a bigger concern, because you might have a endpoint failure, or if you are on a much more smaller bandwidth, you might not get the bandwidth to hit all 4 calls. In that case, RESTful APIs, which are generally optimized for the server, fails miserably. So basically, when you want to put your clients first, or let's say the best part is when these kind of interactions happen, the first thing that every company, even my company, Netflix, Hotstar, have switched back to is called backend for frontends. So they build a small server in between, which is kind of a pass-through server, which collects all the information from the API from the rest of the API servers in the backend, stitches it into one response, and returns it. Now, the best part is here, the client does not have to hit 5 or 4 different services. It can hit one single endpoint and collect all the information. The stitching part is done by the BFF. Now, this begs the question that do we have to need the data requirement of the client? Yes, we need to know what the client wants so that we can stitch the downstream APIs accordingly for the upstream. Now, when you know that the client has certain requirements, or its needs in XML format or JSON format, you will be able to do so. But what if you don't have control over the clients? What if your APIs are public APIs? Then we have a problem, because we don't know what the client wants, at least to build the page, because we don't have control over the client. So that's where GraphQL comes into the picture. So GraphQL essentially is an API technology. It's an API specification. It sits over REST, over HTTP, and it is able to communicate between the client and the server. It is exactly equivalent to what your REST does. It's not very different. You have a response, you have a request, you interact over HTTP. The only difference is it's like a declarative uh, fetching language, as in when in REST you do not have control over what the server returns. So let's say I hit a REST endpoint, I cannot control whether I want name or date of birth. If I just wanted name, still I would receive everything from the server. And this is what is called overfetching in general terms. Okay, so we don't have control over the response from the server. GraphQL is giving you that flexibility. Now, when I say the GraphQL is having that flexibility, what I mean is, let's imagine where SQL came from. You have a select query. You can select the number of columns, as in the columns from which you can get the data from. And then you can say that where do you want this data from, which is coming from the from clause. And you can have filtering as well on top of it. So normally for a REST call, which gives you something like this in return, a GraphQL call would be something like this. So I have just built the servers. You can find the link. I'll share the link over the chat. It's on GitHub. So basically, for a GraphQL, where you need all these data, you will have find user by ID, since 72 is my ID, and I would like to get the name back from the server. So this is the name that the server returns. So if you look at the contract here, the contract is pretty much like whatever you want, you get in the same format. So similarly, if you want address, and in address you want a city and country, server will return that in the same fashion. Okay. Now the best part about GraphQL is you don't have to deal with the overfetching of the data. So you wanted name, you get the name. Somebody who doesn't want name and he wants only the place of birth, he gets the place of birth. And plus the server and the client both can develop independently, as in, let's say client wants to have n number of data where the server develops something else. I mean, let's say a place of birth is a field right now. Okay. And then somebody wants to add the date of birth over here. The client doesn't need to know that. It's equivalent to, it's pretty much decoupled from the server side. Now, there are a few reasons why this technology has prevailed, and it's been in use since 2012, back in when Facebook developed it, the first version of it. And from there, it started kicking off. It went to first the media industry, and then we can see it mostly on the Coursera website. GitHub has implemented this. The reason why this technology has prevailed is it brings the client over the, it gives the client the control to what you need to fetch from the server. Second, it gives a lot of agility to the query that we are posting on. So right now, if you look here, you will find a word called query. I'll come to schema later on in the part. But what has significantly changed is the way we interact with RESTful APIs. So REST used to have something called as get. Okay, here everything is a post. There's no concept of get in GraphQL, and the reason why that has happened is you need some data flowing from the server to the client to from the client to the server to return the resource in the format of. So let's look at the developer tools over here and try figuring out what has exactly happened in the network call. So if you look at the network call, it gives me, let me zoom in a little. Okay, so in network call, we see that you have a payload and it's a post call to the server, and you have a query. So all this, okay, all this has gone in a post call, and the response from the server is this, pretty much what you see on the left hand side. Okay, the moment you say it's a query, it means that nothing is getting modified on the server. So there are a few terms in GraphQL. I'll come to that. So first is GraphQL is a typed language. So let's say you want to have a SQL that says select name, place of birth, and gender from user. User is a table. Select is something you want to get the response in the format of. And there is a where clause here. Okay, the where clause here signifies is in the parameter, and then you have the select in the place of the body of the query. The find user by ID is the name of the query. So if you look at the GraphQL schema definition, it gives you a type. So when you have to implement this from the server side, you will have something called as type. Type signifies the data type, and this is where the GraphQL is a strongly typed language. There are a lot of significance of a typed language. First, you want to have a control over the structure of the data that you want the response in. So let's say when I say gender is a string, here gender is in male, female. So all this becomes string, and this in collection. This is exactly equivalent to how your object-oriented programming works. Okay, there are few reserved types by GraphQL. So one of them is query. That signifies that this particular verb, find user by ID, is going to return you something based on ID, okay, which is passed in a parameter. And this is the return type user. We are going to implement it. Don't worry about it. I'll talk about it more in detail. Okay. The second type, that is mutation, tells that it is again a post type. It's a post call, but there the server changes something in the backend. It is equivalent to a get versus post in REST. In GraphQL, we call it query and mutations. Mutations are generally a type of query, type of verb that signifies that something is going to change on the server side. And subscriptions are more detailed on the it's a little bit more advanced in the nature that when you subscribe to something, it means that whenever something changes in the backend, you get events out of it. So it's based on your event loop, and it's based on WS. It's a little more complicated than query and mutation. Okay, so the significance here of type is very important. So you have to have the structure where you define what is the type of the return that you want to give in. Here it is user, and then in query you define the query of the type. So here, if you look at the documentation, these documentations are all pre-generated. I'll talk about it, how to generate it as well. So you have find user by ID where arguments is in long format. So you can have long int. So there are a few data types that are predefined in GraphQL. So you have string, and these are the return types of it. Okay. So from address, you can again go to the address of the user from recently was. So I'll just write a simple query wherein and I'll compare this query from the RESTful interfaces. Okay, so let's say you want to have the place of birth, date of birth. I have just received a comment telling about subscription. Yes, subscription is a WebSocket equivalent. When you implement subscription, you have to go through WebSockets. That's right. So when you find user by ID, if you want to get recently watched, and then if you want to find the artist, from artist you can go to the name of the artist, and then you have this as the return type. Is the return type mandatory? Okay, so return type here, when you say return type, I assume that you're talking about this return type. As long as you have query tells you that something has to be returned from this particular event that has to happen, then the return type is mandatory. For a general mutation, you can just return a 1 or 0 whether you have ingested the request or not, or if you have rejected the request, which is the change request. But for query, yes, you have to have something in return, because the point of having a query is to get something out from the system. Okay. Now, in recently watched, you have two kinds of artists, two types of artist, and let's say you have a third entity called subscription, and you want to get the end date of the subscription. You want to get the plan details. You have the plan details over here, so you get this kind of return back. Similar thing, if you wanted to do in REST, what you will generally have is a RESTful endpoint of 72 returning you the list of hrefs, and from there you have to have the second hit to get the subscription back, and then from recently watched you will have the third hit, and address and so forth. You have to hit the second, fourth, fifth hits. From subscription you need to go to plan, so you have to hit the fifth and subsequent hits accordingly. So this is overall a brief introduction to GraphQL. I'll move on to the features. So GraphQL has significant features over the rest. So let's say you want to have 72 as the input parameter. You can take this as a query variable here as well. But let's say if you want to have name, okay, name returns you this guy. Okay, so you can actually say that a 72 number ID belongs to this particular person. So let's say we name is as person one. It renames the data. It will, the container in which the data returns as person one. Similarly, if you have to copy this whole thing, and if you have to return person two, okay, so person, this is second person. I just want to get the ID of the person. Well, it's a 68. Okay, it says that you have to change the data type. So you have person one, person two as these. So you can return n number of persons in one call, obviously, and then you have to change the container name, and that's what it was signifying before. So you can manage this independently, or you can take this whole thing and put it inside fragments. Okay, so there are these kind of repetitions that happens, and you can remove this using fragments. So there's one more comment. This is fine when our services are backed by data stores. How about when it works for downstream systems where data is being collected and transformed into view models? Okay, so So it is, so these kind of, so data sources will not matter over here, and I'll come to that part, because this is only the layer that actually gives the API out. It does not tells you where the data is coming from. So when you write the resolver, or when you write the resolution of this data, where the data is coming from, I'll talk about that in the demo as well. We can see that the data is not only coming from database, it's coming from external systems as well. Okay, so to have that, we have to implement, to answer that question completely, I have to implement it. I'll show it over the course of time right now. So right now, if you look at the data structure, it's in this fashion. There are few queries that GraphQL internally runs to build this documentation, which is called introspectable queries. Okay, so whenever your system starts, let's say a normal system, whenever your page starts, it actually builds this particular query, which is called introspection query. It returns you the complete detail of the schema. So if you look at the query, the first thing is underscore schema, which defines you the query type. Okay, and the return for this is basically what is giving you the types. So whatever you see in here is somewhere in the response of this particular introspectable query. So this type of pattern where you have introspection all is generally avoided in production systems, but this is for our clients to build their query and fit it inside their development. So basically this is for your developer experience. Now let's before we go on to implement the GraphQL server, let's look at what it did. So it basically brought each and every client to one endpoint. So if you look at the endpoint over here, it's /GraphQL, and this is the only endpoint. It actually accepts a post request and it returns you all the responses. But this is one endpoint for all the queries. You don't have to manage multiple queries in here, or multiple endpoints for you. So you have less to manage. Now you have one endpoint /GraphQL, which returns you all the data. Okay, so this can act as your gateway for n number of backends. There are some of the performance things that I'll be talking about, but basically, all in all, you have one endpoint to manage for all your data requirements. Okay, there are few problems, or there are few concerns of GraphQL that before going to production we have to care about. Like we have to take care of part of where nesting affects the system. So it's the same kind of problem that happens in JPA. You have n+1 problem, you have nesting problem. So all those problems are getting handled in GraphQL from by data loader and all. I'll quickly brief what is nesting problem. So let's say you have a GraphQL query where you have okay, you don't need subscription, you don't need these. Okay, so a person has there's a query that gives you a person object. Just to keep it simple, I am fetching name and the city of the city from the address. So you get something like this. From the address, I can go back to user, right? Because you have one to many relationship and many to one on the other end. So you have this kind of structure as well. Now from user, you can go back to address again. And from address, you can again consume country. From this address, and you can go back to users, and then so on. So basically you can start from here and start nesting all the way down. So it looks 1 second. Okay, this works. And then from country, I want to get to users. And from user, I can take this whole thing. And then name. So if you look at the return type, it's somewhere equivalent to how your nested queries would look like. This is something that generally happens in production system when the person just want to screw up with your APIs. This can be controlled via, you have something called as depth limiting in GraphQL. So you can control the depth of the query by limiting it to, let's say I want to say that 10 is the number of depths I want to go to. Okay, so these are the few of the concerns that we need to take care in production systems. Okay, let's quickly go to implement one of the GraphQL services. By the way, GraphQL can be implemented in many languages, but right now I would use a normal Spring Boot system to implement it. Okay, hope people are familiar with RESTful service Spring Boot. Okay, so I just want a demo GraphQL, name it that way, and then I just want a logbook and a web dependency. That's all. Demo GraphQL. Okay. Okay, so I will try increasing the font. Font.
1, 2, 3, 4. 4.
Okay, so to start with, I will just need a few dependency in our form. So one of them is from the website where you have GraphQL kind of pre-implemented, you can say so. So I'll use this dependency to start with GraphQL. It's a starter dependency. You will need a Kotlin version defined. You will need a playground dependency where I can write code. I want to change it to playground. And I'll come to Voyager once we have all set. Okay. Let's start with, I would also need a dependency for database H2. And let's say for RESTful APIs, I would need a JPA implementation and yep, and that's all. So let's implement our first hello world in this. Let's say I have a person object, data, all argument constructor, no argument constructor, build private string integer. Let's say give an ID, name. You have a person. I want to mention this as ID, generated value, and I want to mention this as entity. Okay. I would also need a person repo, which will actually fetch me data from instance JPA repository person. Okay. The next thing what I will require is a person schema. Okay. So I'll try building a normal general schema. Okay, I would like to have a person type. Okay, and then I will have an ID of integer and name. So I have ID, which is an int, and name is a string. Okay, you want to have type, and I'll define a query. Okay, I have a comment. I just want to know how address is coming in array format. You have defined address. Return type is array. Yeah, I'll answer that question. Find person by ID. Okay, I can take int and I want to return a person object. Okay, from here, let's say I have a person query and I can define this as service. I have to implement few method, few uh, kind of, you can say few classes for GraphQL to say that how this query is getting resolved in our system. These are few query resolvers that we have to write. Okay, in Spring this is the way. In JS you have an easier way to do it. Okay, but it's there. You can say it's there. So you have ID, you have input coming as 8 ID. Okay, so you have integer and ID, and then this returns me a new person. Okay, person can have a builder as well. Builder. You have to return a person from builder. You can actually wire a for person repo. Email. People need more zoom in there. Is then okay. Sorry for the fonts. You can return person repo dot find by ID, and I can take the input as ID. Okay, and then you want to have a dot get person repo. Okay, now let's build some data in Lake application runner application return new application runner, and let's inject person repo. Oh, I have name, so I will have arrays dot as list name Amar Wiki some name dot for. Person builder dot build dot name, then you can have name in there. Okay, is the ID auto generated? Yes, the ID is auto generated. Okay, so you want to have name over here. Okay, let's see if this works. I'm going to just change the port on which we are running on, 9110. Okay. Hope this works. Okay. Localhost 9110 / playground. Playground is popping fine. Okay. What are my endpoints? I have person by ID. If you look at the documents, it's automatically generated via this GraphQL's schema. So I can have query. I'll zoom in. I'll have query. I'll find person by ID. ID is, what are my IDs? My IDs. So person repository dot find by ID. Or I can have a REST. Have REST repository resource. Okay, that's better. You have Hetios implemented, pre-implemented in Spring Boot, so that will give me the endpoint for all the persons object. So you have a local host 9110 / persons, boom, and that gives me the person object. So the ID is 1 over here. So I'll say ID 1 and give me the name of the person. This will gives me the name of the person. This is one of the ways in which you can say that the person is coming from the repository. Okay. Now let's say the same person, if he wants to come from a from an external resource, you can bind over here. You can have a REST template, or you can have a service written, a proper service written that can have a REST template embedded in it, and then that will call the API, get you the data, and then you can have the response test. This method, if you look at this particular way of writing GraphQL, it has nothing to do with SQL per se. Okay, so somebody talked about address as well, so I'll answer that. So let's say right now your person has address. Okay, so I'll go ahead and implement the address as well. So you have the address. Okay. You need data, builder, all argument constructor, no argument constructor, entity. Okay. Private integer as ID, primarily. Private string city, private string country, private string street name. Okay, maybe. What is it trying for? Generated value. Okay, fine. So you want to have address belongs to a person. Okay, you have many to one, and inside person you have name. Let's say I want to have few more fields over here, age, and then you have one to many. You can define one to many by private list of addresses, addresses, and then you can say this is mapped by, inside address you have person, mapped by person. Okay, so you want to have that the logical relationship being built, and then on the other end you will have person repos. Similarly, you will have an address repository, address repo. then that extends JPA repository address integer rest resource repository rest resource, and that's all. Let's build some data. Address repository. You have person. For building data, let's have a. So I don't want to mention the names myself. Let's have a faker dependency, Java faker. Okay. It is just a minimal class that gives you the ability to fake the data. It has not much of significance. So here, let's say I have a faker object. What happened? And then let's say I want to have 10 of the 10 elements of person. So you have person repo dot save taken as dot name, and then you have faker dot, let's say name dot name. You can have the name dot id is pre-generated. You'll have age faker dot, let's say a number between 20 to 30. Okay. And you can have a person, and then you have a address repo dot save address builder dot city faker dot get address dot get city dot, you have person. I can have the same person which is generated above. You have country faker dot country dot name, and then you will have a street name, let's say faker dot address dot street name. Okay, so I have few person object linking is done. Okay. So what this person object gives. So now the person object gives me the name and the address as well. And the address is populated. So you have this relation find. Say find built by address. Now if I want to have, okay, I haven't mentioned address in here. Name. What do we have? Name and age. Person has name, age as integer. Addresses. I will try having the same value. And this gives me array of addresses. I will try. Now it gives me, I mean, this is just a feature of IntelliJ that proves me to fill the type of address. There's no hard and fast rule there. Let's see, person. You have ID. ID is int. city is string, country is string, and then you will have a person object back, person. This gives GraphQL the ability to query address as well from find person by ID. Okay, so but I'll come to the but part. So this works. Now address, try fetching address from the city. This does not, because it does not know how to resolve address from a person. Okay, so that's where you will need a person resolver. This is where a field resolver, one of the field resolver comes into the picture, where the system does not know how to resolve a person, because if you keep a debug point here, it will actually go and try fetching address, but it won't find it because it's in a different table. JPA will start complaining about the JPA should complain about lazy initialization. So see, person, this address is not there. It says lazy initialization exception. So it does not know how to resolve that. That's where you, in the interest of time, I'm just gonna copy a resolver. It says that you have a person resolver. It resolves a type of person, and it's coming from address. I'll remove the cacheable part for now. Okay, this addresses should match this exactly. This is where your linking happens from a person to an address. And then in an address repository, you will need a resolution for the person. You will need how to get the person from the list of addresses from the person. So I get this, and this is where I get the resolution of the address. Now list here, this is an array, and this is how a list is represented in GraphQL. If someone's asked a question for how do you address a list, and if you right now try looking at address, it will go and resolve the address for you for this particular person. Okay, that's the one of the parts where, before moving on to production, that we want to care about is depth and the complexity. I'll try replicating this scenario over here. So you have name, and then from address, from here, I can take the same address. Okay. System still gives you the value, but if you see, this is what is the depth of this is the depth problem of the recursive query. So every system in Spring Boot, you have depth coming from here, from this property. You can set the depth to 2, and then the moment you do that, it will stop the query by having it will throw an exception. But this is not limited to Spring Boot only. This is just one implementation. This depth is a general concept. It's implemented in JS, TypeScript, anywhere. In all the languages, it does have a support. So you see, now the system won't allow you to fetch this much recursive depth. Okay, you can set this after your load testing is done in production environment. Let the system hang for some time. Let's see how much depth it can handle, and depending upon that. Okay, there are a few things I wanted to catch up before we wrap up. Does anyone have any questions? People can come in. See, no system in production is going to scale without a cache. Okay, that's a very true statement. I mean, without caching, nothing works. So a general perks of RESTful implementations where you have caching and all those, it's available in Spring Boot as well. Okay, I mean, it's available in GraphQL as well. Spring Boot starter cache. Okay, so right now, if you look at, I should have enabled. So right now, if you look at the query pattern, show query, show. Okay. Right now, if you look at the query pattern, the system will keep on querying for each and every implementation, each and every query. So that is pretty much how do we handle authentication if there is only one endpoint. Good question. So authentication is, so if you look at this, it gives some query. So authentication is something that is being handled via normal OAuth. I mean, it has only one endpoint. So basically what you are asking is authorization. I think people who have access to this field, that is more relevant over here. Authentication generally would happen through OAuth. So that's a normal concept. Anyone who has access to this particular service endpoint will have authentication. The main issue is with authorization. So authorization is handled via these resolvers only. So when I say that I have a resolver that can resolve an address from a person. So basically you can start from this node and you can go onto this node, and this is the resolver that is kicking in. Here you can have an annotation of Spring Boot here. Basically you can have restrictions over this particular resolution, this particular data, the request has a particular role. So you can have a normal Spring Boot role authentication, which comes from security, or you can have the normal RBAC call as well. So authorization is handled at the resolver level here. Any other questions? There are a few more. There are a few more production resolution production things that has to happen before production. What do you call the production? How does GraphQL work for custom query of person? So again, GraphQL has nothing to do with the query pattern. It's just the results that matters. So before we move on to custom query is right equivalent to if you write something over here. Okay, so the return of this, so let's say the custom query comes where you have the query interfaces defined. This is where you write the queries over here. You can write @query, then you can write a custom query over here. This has nothing to do with the return type contract. So what comes out of that particular endpoint of that particular method is just an address. As long as this works, the system above it will work. It has nothing to do with how you fetch the data. It's always about the outward facing API, that what the user has queried for is what you get. And the data fetching part can be delegated to a repository here. It could be delegated to a REST template implementation based query. It has all kinds of works. I mean, it doesn't restrict you where you're fetching the data from again. Any other questions? Okay. Yeah. That's all I had in this particular session. There are a few more advanced topics like distributed data. If in ViewClip, what we do is we don't have one GraphQL server. We have micro GraphQL servers, and then those doesn't it make dependent on single endpoint? Yes, it is dependent on single endpoint, but it won't matter much because the endpoint response is based on the query that you write. So each and every query has a different response. So you have city over here. You have you can have why is this server not reachable? Okay. You have country over here. So each endpoint is different. So I mean, in the endpoint request determines the response pattern. So the endpoint does not matter. Endpoint remains the same, but the data is still different because data is dependent on the request. I want to leave you guys with some of the sessions that you can get to. So one is your graphql.org. This is where you can go and learn about how GraphQL was being structured before and how it has come. You can also go and see the specs. You have specifications from the Facebook committee. There are multiple libraries in which GraphQL is implemented right now. One of them is Java. You have native support for JS because it was written in JavaScript before. I love the way TypeScript is being implemented over Express.js, Express Node. So that really gels well. There are different uh, implementations based on the contract that you give. So basically, you have the backend and front end tie-ups here. So you can implement it in Ruby. You can in Python also has a native support. It is called GraphQL Python. You have this very handy tutorial how to GraphQL. You can learn about it completely. It's very beautifully maintained, and the structure of in which the course pursues is very much it. Thanks a lot, guys. Thanks for your time. Have a nice day.